This naturalrefrigerants.com article is being read by an automated voice. The second Industrial Refrigeration Network Conference went beyond ammonia and CO2 refrigeration systems by Michael Hines. Published June 24, 2025. There was no shortage of presentations on ammonia or CO2 refrigeration systems at the second annual Industrial Refrigeration Network IRN conference, organized by Bitzer and held June 6th through 7th in Rottenburg am Neckar, Germany. The IRN conference was held at the Schaeffler Training Academy, Bitzer's International Training Center, which opened in 2016. A total of 130 attendees packed its main conference room for 2 days of presentations from nearly 20 systems manufacturers, OEMs, and contractors. The focus is on safe, future-proof, and energy-efficient solutions based on natural refrigerants and industrial refrigeration, Bitzer said. In addition to presentations on best practices in industrial refrigeration and installations, the program also branched out and included other large-scale refrigeration and heating projects in the HVAC and R industry. These included presentations on a butane high-temperature heat pump, a CO2 chiller used to cool CERN's Large Hadron Collider, and how heat pumps used for district heating can help balance the grid. Industrial refrigeration. Among the industrial refrigeration presenters were Star Refrigeration, Evapco Europe, and Danfoss. Star Refrigeration's Group Sales and Marketing Director, Robert Lamb, presented on optimizing costs, which included a focus on how proper condenser and evaporator fan speed management could cut energy consumption. Evapco's country and branch manager, Michael Robinstein, spoke about the use of hybrid evaporative condensers, those containing a dry and wet coil, in industrial CO2 refrigeration. Data from Evapco showed that a hybrid condenser could enable an industrial CO2 refrigeration system to stay in subcritical mode despite an ambient temperature of 36 degrees Celsius, 96.8 degrees Fahrenheit. Danfoss did a deep dive into NeoCharge, its system for reducing the charge of industrial ammonia systems, at the IRN conference led by advisor Morten Juel Skovrup. Juel Skovrup gave an example of a freezing tunnel in an industrial facility that, using NeoCharge, was able to cut its ammonia charge by 300 kilograms and have enough remaining capacity for a new freezer. HTHPs and CERN. High-temperature heat pumps are a major topic of discussion in Europe as the drive to decarbonize industry and buildings heats up. Jürgen Suess, Business Development Director for DACH at Fenergy, spoke about several of the Danish heat pump manufacturers' district heating installations in Denmark. Suess touched on how, in addition to helping decarbonize district heating systems, which can reach 10 megawatts, 2,843 tons of refrigeration, in size, Fenergy's air source CO2 heat pumps can assist with grid balancing by starting in under 5 minutes. Its heat pumps can reach outlet temperatures of 90 degrees Celsius, 194 degrees Fahrenheit, with a propane isobutane setup. Sven Limpeck, sales manager for Germany at Voteris, and Tim Hamaker, managing director at SPH, spoke about a butane high-temperature heat pump they're working on that produces steam at up to 115 degrees Celsius, that is then lifted to 195 degrees Celsius via a mechanical vapor recompression system. SPH's heat pump utilizes Voteris's plate and shell heat exchangers and will be installed at the Takeda's Viennese production facility of Takeda, a subsidiary of global biopharmaceutical company Takeda Pharmaceutical. Dirk Leuteritz, head of sales at refrigeration systems manufacturer Compact Keltetechnik, and Robert Funke, international sales at refrigeration systems contractor InfraSolution, presented one of the IRN conference's most unique projects. The German companies collaborated on a 1.3 megawatt, 369-ton refrigeration CO2 chiller that cools the silicon detectors, used to track particles from proton collisions, in CERN's Large Hadron Collider, which is located near Geneva. In addition to maintaining an evaporator temperature of minus 53 degrees Celsius, minus 63.4 degrees Fahrenheit, the Large Hadron Collider's underground location meant the evaporator and condenser were separated by 90 meters, 295 feet.